Okay, grade 8s, we're going to go over some more fraction skills today. I'm going to try to do it a little bit faster today. So we're going to start off with equivalent fractions, which I'm sure you've heard of before. Equivalent fractions are just different numbers, they're different fractions, but they actually represent the same amount of a whole, so they're the same size. So for example, let's take a look at this fraction right here. Which fraction is represented here? Well, we've taken the circle and split it into 3 equal pieces, and remember that's the denominator. It tells you how big the pieces are, or how many pieces you cut the whole into. And how many are shaded? 2. So this is your fraction right there. Now, is it possible to represent this differently? Yes, it is. What if I split each one of these sections in half? So, like this. You have to excuse me if I don't do it perfectly, but I'll do the best I can. Okay, take a look at it now. How many sections is it now look like it's split into? It's split into 1, 2, 3, 4, 5, 6. So now the bottom number is actually going to be 6, isn't it? So denominator is 6. And how much is shaded? 1, 2, 3, 4. So 4 over 6. And you know what? I haven't shaded any more. I haven't shaded any less. It's still shaded the exact same amount. So 4 over 6 and 2 over 3 must be exactly equal to each other. And they are. They're equivalent fractions. Guess what I could do again? I could split them again. So I'll very quickly do that. Okay, it's really not looking that great anymore, but hopefully you get the idea. How many pieces are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's now 12 pieces. So my denominator in my new fraction is 12. How many of them are shaded? 1, 2, 3, 4, 5, 6, 7, 8 are shaded. So this fraction, 8 over 12, must also be equal to 4/6 and also equal to 2/3, and it is. We could keep doing this over and over and over and generating more and more equivalent fractions. Now, what about when we don't have actual pies staring us in the face, but we just have fractions? How do we get equivalent fractions? Basically what you do is we multiply, or divide if you want, but usually we multiply, the numerator and denominator, it should not say or, that should say and there, by the same number. So let's start with some fraction. Let's start with 4 over 5. And I want to get an equivalent fraction. So I'm going to multiply the top and the bottom by the same thing. Now what won't work is if I multiply by 0. If I multiply by 0, I'm going to get 0 over 0. That's definitely not equivalent. So don't multiply by 0. Don't multiply by 1 either. If you multiply by 1, you're going to get 4 over 5. It just stays the same. But if you multiply by anything else, you can get an equivalent fraction. Now, don't multiply by a decimal or something weird like that. Multiply by something easy. I don't know. Start with 2. If I multiply by 2, I get 8 over 10. So that is definitely an equivalent fraction. What if I don't multiply by 2? What if I multiply by 3 or 4? Or, I don't know, I'll multiply by 5. I can do any number. 4 times 5 is 20. 5 times 5 is 25. So this must also be equivalent. What if I do a big number? What if instead of doing 2 or 5 or whatever I did, what if I do it by 100? That'll work. 400 over 500. It doesn't matter. As long as you're multiplying by the same thing on top and bottom, you'll get an equivalent fraction. So the question I have here is, are these following pairs of fractions equivalent? So I have 2/3 and 10/15, and I want to know if they're equivalent or not. So what you could do is you could ask yourself, well, what did I have to multiply 2 by to get 10? I'd need to multiply it by 5. What I do the top, I got to do the bottom as well. Is that what we multiplied 3 by to get 15? Did I multiply by 5? Absolutely. So yes, this one is equivalent. Let's look at the next one. What did I multiply 30 by to get 5? Wait a minute, I probably didn't multiply 30 by something. I probably divided by something. What did I divide 30 by to get 5? I divide by 6. What did I do at the top? I also do the bottom. Divide by 6. Is 42 divided by 6 7? Yeah, it is. So this one's also equivalent. By the way, there's another way to do this, probably a more common way to do this. Just look the other direction. Rather than going from 30 to 5, go from 5 to 30. What do you do to go from 5 to 30? Multiply by 6. Did it work when I went over here as well? Yep. 7 times 6 is 42. So this one's good. Okay, next one. 4 to 12. Well, I guess I had to multiply by 3. 5 to 20. Wait a minute. I multiplied by 4. So this one is not equivalent. It says to change the second fraction so they are. Well, you have a choice. You can either multiply top and bottom by 3, in which case you'd get 12, like you already have, and 5 times 3 is 15, so that would work. Or multiply top and bottom by 4, in which case you'd get the bottom number is 20, just like you have here, and the top number would be 16. So I guess either one of those are good answers in this case. Okay, last one. 20 and 18. What did you multiply 20 by? What did you divide? Whoa, this is looking really hard. You know what we might want to do here? Put them in lowest terms, and then see if you get lucky, and maybe it'll work better that way. So let's put these in lowest terms. The first fraction is 20 over 30. Hey, look at that 0 sitting there in both of them. Remember what that means you can divide by? 10. 20 divided by 10 is 2. 30 divided by 10 is 3. Okay, want to put this one in lowest terms too? You could divide them both by 9. 18 by 9 is 2. 27 divided by 9 is 3. Oh wait, 2/3 equals 2/3? This looks promising. Yes, these were equivalent fractions. Alright, mixed fractions and improper fractions. You know the difference between these? A mixed fraction is also called a mixed number, but in Canada we usually call it a mixed fraction. And it consists of a whole number and a fraction. So just to give you an example, it'd be something like 7, there's the whole number, and 1/8. So, 7 wholes and 1/8 of a whole as well. And then there's improper fractions. Improper fractions are also called top-heavy fractions. At least some kid once told me that, and I love it. Top-heavy is such a good name. The reason I don't like improper is because improper makes it sound like there's something wrong with it. There's nothing wrong with improper fraction. So what is an improper fraction? It's when the numerator is bigger than the denominator. So, for example, something like 13 over 4. Look at 13 is bigger than 4. Let's write this as a mixed fraction, and let's write this as an improper fraction. So we're looking at the whole thing here. So if we did mixed, you'd look first of all, how many whole complete things do you have? Well, this one right here is a whole complete item. So that would be 1. And then if I look at this one, what fraction is represented here? Well, my whole is split into 1, 2, 3, 4, 5, 6 pieces, so my bottom number is going to be 6. And how many of them are shaded in? There's 1, 2, 3, 4 of them shaded in. So 1 and 4 out of 6. By the way, you could put that in lowest terms, couldn't you? It would also be 1 and 2 out of 3 you could also put. But for now, let's just worry about this, the 1 and 4 over 6. Okay, now let's do it improper fraction. So improper fraction, you again ask, what size pieces are these? You've divided your whole into 6 in both cases, so your bottom number is 6. But how many total are there? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 of them shaded. So it's actually 10 over 6. These two things are equal to each other. 1 and 4 over 6 and 10, 6 are equal to each other. How do you get in those terms? Divide them both by 2. 10 by 2 is 5. 6 by 2 is 3. It's equal to this. It's the same. Okay, so what we need to learn how to do is to switch from mixed to improper and improper to mixed. So let's start with mixed to improper. Let's look over here again. So let's write this in mixed form. You have 1 whole. You have 2 wholes. So you got a big 2. And then what's our fraction here? There's 1, 2, 3, 4, 5 pieces and 2 are shaded, so it's 2/5. Okay, now let's think about this for a second. If I was going to count up all the pieces to do my improper form, what's a fast way I could do it? Since I know this is cut into 5, and I know this is cut into 5 pieces. It takes too long to go 1, 2, 3, 4, 5, 6, 7. Why don't we just do this? We see there's 2 holes, and each one of them has 5 pieces in it. So we would do 2 times 5, wouldn't we? And then we would add on these extra 2. And that's exactly what you're going to do. You're going to go 2 times 5 plus 2. 2 times 5 plus 2. Now, when it's improper, the pieces don't change sizes. They're still the same size. They're fifths, so your bottom number is going to be 5. 2 times 5 is 10 plus 2 is 12 over 5. So here's how you do it, if that didn't make sense. To get the new numerator, you take the whole number, in this case it was 2, you multiply it by the denominator, in this case it's 5, and then you add the numerator, which in this case was 2, this 2 here. The denominator just stays the same. Okay, and that's how you switch from mixed to improper. So if we take a look at the first one here, it is 2 3/5. It's exactly the same as what we have up here, except one more is shaded in. So it's like this. So again, whether I'm talking mixed or improper, the size of the pieces stays the same. They're fifths. So you know for sure your bottom number is going to be 5. Now for the top number, all you need to do is count up all these red ones. But again, remember, fast way to do that? I know there's 5 here because it's in fifths. I know there's 5 here because it's in fifths. So I go 2 times 5 to get this amount right here, and then add on the 3 that are right there. Or if you look at it here, 2 times 5, multiply those together, 2 times 5 is 10, plus 3 is 13. Don't believe me? Count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so it's a fast way of doing this. Next one, multiply the whole number by the denominator. 9 times 10 is 90, plus 1 is 91. So again, that's like there's 9 wholes, and each whole has 10 pieces. So 9 times 10 is 90, and you have 1 extra. That's the 91. Pieces stay the same size. They're still tenths. This one as well. Pieces stay the same size. They're eighths. You have 6 wholes. Each one of them has 8 pieces in it. So 6 times 8 is 48. Add 7 more. You're up to 55. This one here. Pieces stay the same size. They're 11ths. You have 3 wholes. Each one of them has 11 pieces. 3 times 11 is 33. Plus 2 is 35. That's how you go from mixed to improper. How about improper to mixed? Well, let's write this improper form first. So in all of our wholes here, we have 1, 2, 3, 4 pieces. So our bottom number is going to be 4. Now how many pieces total do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This fraction is 18 quarters. Ugh, it's not in lowest terms, but oh well, we'll go with it. 18 quarters. Now, if I wanted to write this in mixed form, what I would need to know is how many wholes are there? Well, I can count them. There's 1 hole here, there's a 2nd hole here, there's a 3rd hole here, there's a 4th hole here. So it should be 4. But wait a minute, what if I couldn't see this? What if I covered this up and you couldn't see how many holes there were? You were just going by this. Well, remember, every time you have 4, it's a hole. So how many 4s can you get in 18? You can get 4 4s. How many are left over? 2. So that's why you will still have 2 out of 4, right? This fraction right here is 2 shaded, that's the top, out of 4 total, that's the bottom. So there's your answer. Not in lowest terms, but that's what we'll do. So what are your steps for improper to mixed? To get the whole number, you ask yourself, how many times does the denominator go into the numerator? So in this case, how many times does 4 go into 18? It goes in 4 times. That gets us up to 16. Now to get the new numerator, it's just how much is left over. 4 times 4 is 16 with a remainder of 2. So there's our remainder. And then the denominator stays the same. Okay, so let's switch some of these into mixed form. So 10 thirds. So let's just think of a hole here for a second. Okay, here's a hole. A hole is made up of 3 pieces. Every time you have 3 pieces shaded, you get a hole. We have 10 pieces shaded. So how many of these could you make? You could make 3 of these guys, couldn't you? Yes, 3 goes into 10 3 times. That gives you 9 pieces. If you had 3 of these ones, you'd have 1, 2, 3, another 4, 5, 6, 7, 8, 9. You'd have 9 pieces. You'd have 1 left over. And the pieces stay the same size. They're still thirds. So again, if that's too confusing with the drawing, 3 goes into 10 3 times. That gets you up to 9. So you have 1 left over. The denominator stays the same. If you want, put the denominator down right away. Denominator always stays the same. Okay. 4 goes into 43. Oh my gosh. 4 goes into 43 10 times. That gets you up to 40. How much is left over to get up to 43? You still have 3 left over. Okay, put the denominator down right away if you want. 7 goes into 37. How many times? 5 times. You can get 5 holes out of this. Every 7 you get a hole. 5 times 7 is 35. So it's 35 pieces taken up. You still have 2 more. The remainder is 2. So 5 and 2 sevenths. 11 to 100. Keep the denominator the same. It's going to be 11. How many times does 11 go into 100? 9 times. If you have 9 holes and each hole is 11 pieces, 9 times 11 takes you up to 99 pieces. How many are left over? What's the remainder? 1 lonely piece. So there's your 1/11th. Alright, these are really important skills, so please make sure you learn how to switch from mixed to improper and improper to mixed. Thanks, and let me know if you need any help with that. Take care.